I'll show how to create a production-ready web service in a few easy steps. First, I create a collection where we can store all the objects we will create for this project. Next, I'll create a microservice object. I name it Calculate Average. Microservice objects allow us to write some JavaScript that will be executed using Node.js on Amazon Lambda. The main thing for us to know is that any data passed to the service as JSON is available to us in the variable input, and that we need to call a function kb with our result. The first parameter here would be something other than null if we wanted to report an error with our service. This and everything else about the API for microservices is also available in our documentation, which can be opened by clicking here. So, as said, the input passed to our service is assigned to the input variable. Let's expect a property numbers here, which contains a set of numbers we want to calculate the average from. When this property is not provided, we issue an error with the callback function. We will now add a check if all elements in the numbers array are actually numbers. For this, we first create a little helper library. I go to the browser and create a new micro-library with the name isNumber. Micro-libraries are small, reusable pieces of JavaScript code. Anything I attach to the variable lib will be exported. So here I export a function validate and add some JavaScript to check if the passed parameter is a number. Now I go back to my microservice and loop through the numbers array. I can drag and drop the isNumber micro-library in here to check each argument and issue an error if it's not valid. We are now going to actually calculate the average. For this, I use an existing NPM library, mass.js. I can import it by going to the dependencies and selecting NPM packages. Here, I now add the mass.js dependency with the latest version I want to use. Now I call the function mean from this library and return the result using the callback function. I can test this library on the Test tab. I provide a JSON here with a numbers array. And if I run this, I get the average as the result. Finally, I can deploy a production version of this service on the Deploy tab. A deployed production version will not change when I continue to develop my microservice until I release a new production version. I can grab an endpoint to the production version and call this from any app that supports HTTP requests. So that was all for creating a simple microservice. As you can see, if you just need a service for simple tasks that you need to run scalable and secure in the cloud, you can create a new microservice object in a few seconds. Even better, you can use micro-library objects to break up your JavaScript code into small, manageable, and reusable pieces. So you can use ObjectHub solely for developing the backend of your mobile apps and web pages, but you can also use it to develop user interfaces, which we will show in the next tutorial.
In this video, I'll show how to create a production-ready web application in a few simple steps. For this, I first create a micro app. I name it 2 kilometer run. Micro apps are small reusable pieces of user interface. They consist of vanilla HTML, JavaScript, and CSS code. Let me show you how this works. First, I define some HTML. For now, just a heading and a button. If I head over to the CSS tab, I can change the appearance of elements in the HTML. For instance, add a color to the heading. If I go to the JS tab, I can interact with the elements defined in the HTML using jQuery. For instance, I can add a click listener to the button. I use the data action attribute to identify the button. And define the listener function. Okay, just got to type it right. Okay, now note that I provide additional argument elem here. This executes a jQuery query in the context of the app and not the whole page. Now I just let it display an alert here. And you can find more infos about how to work with micro apps and write JavaScript for them by looking at the documentation, which can be accessed through the help button. As you can see, we learn about how to write the HTML, CSS, and JavaScript for these apps. Now I can go to the preview by going here, and I can test the preview too. You see the alert comes up when I click the button. So, but now to the core of what this app should do. We want the user to be able to enter lap times and then calculate an average for all the laps which they have run. One thing missing in our app is a way to enter the times for multiple laps. We do this by creating a second micro app. I call it laps list. Here in the HTML, I add an input to provide a time. And a button to submit it. And finally, a div where the times can be listed. Now in the JavaScript, I link to the click event of the button. And in here, I grab the value from the input. And now I display the value in the div, again by accessing it using jQuery. Now, in addition, I define an array here, which is called values. And I also add the value I grab from the input to this. However, since I would like to deal with integers, I just convert this to a number. And now we need to know that everything that is attached to the app variable in a micro app is exported and thereby visible to other micro apps. I go back to the original micro app and drag and drop the list onto the HTML. That will embed this micro app into the 2 kilometer run micro app. Now, if I click on the button, I would first like to grab the values from this list and then submit them to the service we have developed in the second core tutorial. To link to the service, I can again just drag and drop it onto my code, the JavaScript here in particular. Now I also need to submit a JSON message, and calling the service requires calling the apply method. I'll just make a little bit more space here, which returns with the result from the service. So now let's go to composing the JSON message. And here our service expected one property, numbers. So that makes the message complete. Now we need to deal with the result. If there's something in the variable x, then this indicates something went wrong with calling our service. And we just issue an alert here. And otherwise, REST contains the JSON object created by our service. But before, we need to have a little space where we can display the result. I just use a span here. Grab this attribute to identify it. Again, with the little jQuery query. Never to forget the alum. And so what we want to display here is simply a property of the return JSON and specifically the average property. Now we can quickly test this app. Just adding some numbers here and then clicking calculate average. And it returns us the correct average. One thing to note here is that you might be wondering where the rest of our HTML is. So the HTML we have to find on the HTML tab is of course what is essential for our app. But we all know there's some other stuff required to make a complete HTML page. This HTML is what we call the wrapper used for the app. The wrapper HTML can be accessed through this button here. Usually we use a pre-made template like this with some core dependency defined already for us, but you can change it to anything you like. We can also deploy this app into production. For this, we go to the Deploy tab and deploy it. This will compile the app with all its dependencies into a nicely packaged bundle. If we change the app or any of its dependencies, it won't affect this deployed version. Now I can open it, and it opens here. The performance of deployed apps is much better than those in a preview, since all dependencies are compressed into one file and the HTML of the page is pre-rendered during deployment. We can give the link generated during deployment to our users. The link can be accessed through here, but often we would like to give something with a little bit nicer URL. For this, we can use a domain object. I first search here for the domain object template. Select it, and I give it the name 2km. With a domain object, I can either use a free subdomain on ObjectHub, or I can link it to my own domain if I can set the DNS records for this domain. I just provide a domain name here and go back to the browser and to my objects I've created and drag and drop the 2km RAN app into here. Just click link this domain and object, and now I just set it here to use the production version, and the app is now available on this subdomain. So now we have shown how to create a web service and link this web service with a web application. In the next tutorial, I'll be showing how to work with persisted data. In this last tutorial, we'll add persistence capabilities to our app. You can use ObjectHub with any persistence backend, which supports a REST API, such as CouchDB or Amazon DynamoDB. However, we can be the most productive if we use StellarDB as a persistence backend for ObjectHub. ObjectHub itself is based on this database, and we have plenty of tools in ObjectHub for working with StellarDB data. The first thing we do is to create a database. This is done by simply forking a database object. I name it runs. A database is just a place in which we can store as many objects as we like. Databases also support SQL replication. SQL replication will turn the data of objects we add to this database into MySQL tables, which lets us query these tables very easily. Next, I'm going to create a template for the data which is to be added to the database. For this, I fork the data object template. I name this run. Data objects describe a small unit of graph data. So everything inside a data object is a node within a small graph. I create a new node here with the type number. I put this under the path time. This should be the node that will contain one time measurement from our app. And I create another number node, this one under the path distance, which will contain the distance that has been run. Next, for SQL replication to work, I need to add a class and two attribute types to this data. These are again just normal objects. So first I create a class. I name this run. And we need to know that classes will map to SQL tables. So in my replicated data, I'll have a table with the name run. Next, I create an attribute. I name it time. And attributes are mapped to columns of an SQL table. So this one here will map to a column named time. I also create a second attribute. I call distance. Now I go back to my data object, and here I drag and drop the attributes types towards the matching nodes. So time for my time and distance for distance. And finally, this overall thing here is of the class run. So I take the run object and add it just somewhere here right in the data. So now here to recapitulate, I have created this data object, and this data object contains a number of nodes. One of the nodes has a time path, and it has also attached an attribute of the type time, and this is a number, and this number will contain the time it takes to complete a run. The second attribute here is the time it takes to, or is the distance that you have traveled for completing a run. And finally, this overall data object, I have added a class object run, which tells the StellarDB engine that this object, this overall object, is a run, and as such, the attributes of this should be mapped into the run table. So if I add a time and distance here, that will create a row in a run table with the matching time and distance. Now I store the data in a new web service. So I create a microservice object here, and I just name it store run. And in this web service, I use the databases API to create a new sub-database in the runs database. And to know that we want to have it created right in this database, we can again just go and drag and drop this object over here and add it to our source code. Now, more infos about the databases API and all other APIs which belong to the StellarDB database engine, we can find in the ObjectHub documentation here under StellarDB, and then here we can see the different APIs that we need to work with StellarDB, and one of them here is the databases API, and I just used the operation create, and here we can find all the information about that. To run this operation, I need to call the apply function again. And check for an error. And here it will provide us with the error in this variable. And if it succeeds, it will give us a reference to a database object in this parameter. So if I have a database, then I can now access the root node of this database by calling db.root, because every database I create again creates a small space of graph data in which I can store whatever I like. And the root node of this graph data, it can be accessed by calling db.root. And now what do I want to put into this database? Well, I want to put the information from this template that we have created. And I can do that very easily by copying the data from this data object into my new database. And for this, I can use another API from StellarDB, which is the operations API. And here we have the merge to operation. which we can use for this purpose. So we take as the origin node the template we have created. Again, just drag and drop it onto the code. And then we want to merge this data with the root node of the new database. Again, to actually run this application, we need to call the apply function, which again will provide us with an error if something went wrong. And otherwise, we get as result the root node of the newly merged data, which will be the same as the root node of the newly created database. Now, the next question is, what data should I write into this database? Because for now, I've just copied the template, and that should be something that is provided to me in the input variable for this web service. So let's check if we get a time and a distance parameter. And if we don't, then we issue an error. But if we do, we can use these values and now store them in our data. And for this, I use another API from StellarDB, which is the Graph API. And I proceed as follows. I take the root node of my database, and now this is a part of a small graph. And now I can navigate in this graph by using the select operation. And this again is documented in the StellarDB documentation here under Graph API, and then the various select operations here we can use to navigate the graph. And I specifically here use the select path operation. And one path that I created here was the path time. And the time, now this will give me the node that corresponds to exactly this node here in the template. And now what I can do is I can set the value of this node to the time that was provided to me as input to the web service. And I proceed in the same way for the distance. So what I've been doing here is I first created a new database using the database API, and then I took the template of this data object run and copied it into this database using the merge to operation, and then set some of the attributes of this to the values that have been passed to me. And now we can have a look at this data object here, and we can see that there is some additional information in here. One is called a version node, which helps us to, if we later upgrade our data, our application and our data changes, we can use this to see, with which version of the data we are dealing. And there's also this meta node here. And the meta node contains metadata about the object, which is this data object. So here we can see, for instance, the title run that matches exactly to the title here that is displayed, and that is displayed also here. And we have a whole bunch of other metadata for this object as well. And this metadata, it's the same for any type of object. So not just for these data objects, but also for the domain objects, micro apps, and microservices. And why is this important for us now? Well, we would like to give the new run data object that we create a matching title so that we can easily identify it. And that we can do fairly easily by just selecting the title node, which is under this path, and then setting a nice title for it. For instance, just the distance, and then followed by the time in seconds. And the distance, let's say we provide it in meters. Now let's tidy this up. Right, and finally, we need to commit the changes that we have made to the data. And again, to actually trigger the operation, we need to call apply. If an error occurs, we report it. And if no error is reported, we return a success message. And this little callback here we remove because we should only have one path going through our application, which will be this one. Now I can go back to my 2-kilometer run micro app, and I add an additional button here which triggers the storage of data. And again, I use jQuery to bind the click event for this button. Not to forget the elem for the right context. And I use the services API to post to the new service we have just developed. A message. Again, just give some more space. Check for an error. Now sort out what message we want to send. And as we just saw, we need one property time here and one property distance. Now distance, this is our 2-kilometer run app, so that will be 2000 meters. And the time is the total time of all lap times, which we have to calculate. We can just do quickly with the for loop. Through the values from our lap list micro app. All right, let's test this. Again, add some values. And now I just click Store Data. And now when I go to the runs database, see here that a new database has been created with values as we would expect. Time of 60, which is a total of all the lap times are added, and a distance of 2000. Also, the data we have added will magically appear in the SQL tables for this database. So we see here now there's a table run, And if we open it, we can see that there's a new entry here with the time and the distance that we have just declared. Let's say we are not so concerned with the privacy of this data. Then we can go into here, into Manage and Data, and we can enable public read access to this database for everybody. This will enable us to run SQL queries against this database directly from our app, which I will quickly demonstrate. So back to the 2-kilometer run micro app. Here I can add a little place where the average of all my runs is displayed. The calculation of this I do in a little helper function. I can declare anywhere here. Just referencing the span I just created. And now how do I calculate it? Well, for this I'll use a SQL API again, which is documented under the StellarDB APIs. And here specifically I use the query function, which is easy enough to use. So I just define the context where I want to run my query, which is the runs database. Then I can go ahead and write my query. Now, because this is a 2-kilometer run app, of course, it should only be for the 2-kilometer runs. And again, to actually run this, I will call the apply function. And again, if something went wrong, an exception will be reported. And if not, the table resulting from this query will be stored in the res variable. And here my result will be in the first row. And here the column name will be AVG time. And this I want to display in the span. Finally, I need to call this function as well, which I do here in the init. And after new data has been stored. And let's have a look at the preview. Need to reload it. We can see here it shows us the average. So this concludes our series of core tutorials. You can find plenty more information in the ObjectHub documentation. If you have any questions, why not get in touch with us? We are looking forward to hearing from you. You can just click this button over here and write us a message.